With this video, I want to go over section 3.4 of my slides. And in 3.4, we're going to be solving rational equations, equations that have numerator and denominator or fractions, and radical equations, equations that have square roots. So here we're going to solve for x. We have a radical. Here's our fraction for both of them. I know this is everybody's favorite material as far as trying to get rid of fractions, but hopefully this video and the way I explain will make it a little easier for us to eliminate the rational part of it, which is the fraction, and then solve for x. So here's my equation, say equal to 0. The way I have it set up on the slides, or if you read in the book or even view an example, I think this is a long way of doing it. There's nothing wrong with it. So if you understand how to get the LCD to be 6 and over here. So basically what they're doing is find the LCD of the denominators, which in this case is going to be 6, the um, the least common denominator. So what is the smallest number that both the 2 and the 3 can go into? So if we make a list, we know the 3 goes 3, 6, 9, 12, so forth. We have 2, 4, 6. 6 is what they both have in common and is the least number. So that's what the LCD is. And I'll show you how to find the LCD with variables and making a chart. So what we do is take that LCD, which is 6, and multiply it to both sides. So the little shortcut that you can do is if we take the LCD divided by the 3, that gives us 2. We can put that in front. Once you do that, you can get rid of the 3. So this 6 times over here, so you distribute, take this 6 over here. So what we're going to do first is take the 6 divided by this 2, that gives us a 3. Now we can just get rid of the 2 and 3. We can actually solve this equation without any rational functions inside of the equation. So here we distribute the 2. 2 times here gives us 2x. 2 times minus 8 gives us the negative 16. And 3 times for both of these gives us 3x minus 9. Combine like terms. To move the 5 over by dividing, we get x equals to 5. Put this 5 back in for this x. And this x here. Make sure everything, once we do the math, it equals out to 0. Then I know this 5 is correct. So always do the check after you finish. So that's one of the ways of doing the LCD is find the LCD, multiply to this side of the equation and this side of the equal sign, simplify, distribute, collect like terms, and then we have the answer to be x equals to 5. If the denominators actually are exactly the same on both sides of the equal sign, you can just automatically just cross them out. We don't need them anymore. That's only if the denominator matches the denominator on both sides of the equation. If you have some other stuff, you can't do that. So, but if it's just exactly the same, cross them out, and all we have now is just x squared equals 9. To get rid of the square, we take the square root of both sides. Remember, when you do the square root, you have your plus and your minus. We're going to do our check just to make sure everything works. If I try negative 3, put in the equation, both sides is going to equal to be true. If you do 3, put it into the problem is not defined. So this is a good example for when you're doing your tests or even on the homework assignments. Do not put in negative 3 and 3 to be the answer for x for this particular problem. You always have to do our check to make sure that both of them are the answer, because in this case here, the positive 3 did not work and is not defined. So here is the equation. Now we got to find the LCD of 3x plus 6, x squared minus 4, x minus 2. This is a little bit more complicated because they're not just numbers. So I'm going to go to my whiteboard, and I already have the equation already set up. So to start off, you're going to make yourself a chart. Put only denominators in the first column. So 3x plus 6, 3x plus 6, x squared minus 4, and then x minus 2 in our first column. The next we're going to do is we're going to factor. How can we break this apart into two things being multiplied together? Well, I notice I can factor out a 3 here. So if I factor out a 3 here and a 3 here, what does that leave me with? So over here, it's going to be, if I factor out a 3, it's going to leave me with just x. If I factor out a 3 here, it's going to be plus 2. So if, just to check, make sure we do a check. If I multiply this back in, that gives us the 3x plus 6. So I'm going to put my 3 in one box, and then my x plus 2 in the next column. Remember, when we multiply these two together, they make sure they equal what we originally put in our first column. Here I have this is what's called a difference of squares. So if I have a difference of squares, the rule is I can write my two parentheses. I take the square root of the first term here, that's giving me my x and x. Then I take the square root of my second term, that gives me 2 and 2. Because this is a minus sign, not a plus sign, but a minus, that's why it's called difference of squares. I know I can always put a plus minus in the two factors. So if you always want to check, just multiply it straight out. You should get the middle term should go away, and you should just have two terms here. So we're going to put this in our chart. Now, the most important thing is make sure they all line up in the same column. I don't have a 3 here, so I'm going to skip this, but I do have an x plus 2. That came from right here. X minus 2, so this gets its own little block, like so. So once again, when we're looking down at this problem, make sure all the numbers are matching. They all line up and match, looking out each one of these. Let's do our last one. X minus 2, this looks like it can't be factored, or it can't at all. We can't factor out anything. We can't break it down. So we just go ahead and put it in our chart. I'm not going to put it here because it doesn't match with the 3. So we're not going to do that. We can't also put it in the second column because that second column is already designated to be a plus sign. So what we're going to do is we're going to put it in the last column, because this is where they match up at. Let's get this all erased so we can have some space. Okay. So the next part of this problem here, we want to bring down one item from each column. So I'll bring down the 3, and I'll put a little cloud around it. I know I see 2x plus 2's, but remember, only bring down 1 from each column. And then x minus 2. If we multiply all together, now you don't have to actually physically calculate and multiply together. You can leave everything separate, but this is considered to be my LCD. 3 times x plus 2, x minus 2. We can leave it separated like that, but that's going to be our LCD in the problem. So what do we do with the LCD? We take the LCD and multiply it to each part. Now here's a little bit of a shortcut. If I look at the row of 3x plus 6, I notice that it's missing something here. That missing part here, if you can figure out what that missing part by just looking down, it looks like it's missing an x minus 2. So because it's missing an x minus 2, this is the only thing that gets multiplied just to the numerator. And we can get rid of the denominator. That's the cool thing about this. Figure out what's missing in the row, multiply it just to the numerator, and then you don't have to worry about the denominator anymore. So looking at this one here, I'm going to say 2 times what was missing was the x minus 2. All right, so let's do the second one. So if we look here in the second one and look here, it's missing a 3. So we come down here, multiply that 3 by the 1, which is still 3, and I can get rid of the denominator. Real cool. The last one here, we're going to look in the last row. And it's missing two things. It's missing a 3, and it's missing an x plus 2. So this is where we're going to multiply both to the numerator on top. So I have 3 times this 4 times x plus 2, and then I can get rid of the bottom part. Now let's combine like terms and simplify this problem out. I distribute, I have 2x minus 2. I'm sorry, not minus 2, it's going to be 4, because I got to distribute. Plus 3 is equal to 3 times 4 is 12. And remember, I'm going to multiply that 12 inside of both. That's going to be 12 plus 24. So combine like terms here, I'm going to have 2x minus 1 is equal to 12x plus 24. I like to build a little wall here to keep everything separated. So I'll move things over now to the left and the right side. So I'm going to minus this 2x over here, minus the 2x over here. And because I brought the 2x to the right side, I need to bring something from the left side to the right. From the right side to the left side. So we're going to move the 24. So minus 24, minus 24. So in this problem here, the 2x's cancel out and the 24's cancel out. So over here, I'm left with minus 25 is equal to 10x. So divide both sides by 10. I reduce, so x should equal negative 5 over 2. So here we get the exact same answer of negative 5 over 2. Once again, if you kind of understand why the way the book on my MathHouse Plus doesn't view an example, you're more than welcome to do it this way. But I kind of like laying it out, putting it in the chart so I know where everything comes from, find out what's missing, multiply that missing part just to the numerator, and get rid of the denominator, and then go ahead and solve for x. Now let's talk about radicals. One of the key things about radical is when you're trying to solve for x and using radicals, you kind of want to always get the radical by itself and move everything else onto the other side of the equation. That makes the problem a lot easier to solve. Because when we have the same exact power, the bases are equal to each other. That's what's called the principle of power rule. So here, we don't really have to do any moving anything over because the square root is on the left side and there's nothing else in front of the square root here. There's nothing added or subtracted to it. It's just the square root, which makes the problem a whole lot easier to do. So for here, all we do is square both sides. Anytime you want to get rid of a square root, you square it. We got to do to this side also. That drops the square root, leaving you with just what's in the inside. And then 4 squared is 16. Go ahead and solve for x. We get x equals to 5. Make sure you plug the 5 back in. If it's true, which it is, that's going to be our solution. So over here, we see that now the 5 is being added to the square root. Again, the number one thing you want to do is make sure the square root is by itself. The 5 has to go. It makes the problem too much complicated by doing the whole square root. And I'm going to show you a rule, or not necessarily a rule, but a red flag that students are allowed to do when they have this 5 here, what they want to try to do. So here's the same equation, and this is where sometimes where students get into trouble. The red flag I was saying, we know how to get rid of a square root. In order to get rid of the square root, you got to square it. So what some of my students usually do is they'll put a square here, a square here, and a square. I'm putting in red because this is a no-no. Don't do this and don't copy this. They'll say 25 plus x plus 7 is equal to x squared. That is such a no-no, and when it comes to math, illegal. Don't do it. So let's get rid of all this stuff. So back to our rule, again, when we want to try to get a square root by itself, if you're trying to square it, the proper way to do it, or the legal way to do it, is to take the whole thing and square it, like so. But who wants to multiply this out? This can look really, really messy once you finish it out. We have to do the 5 when we FOIL. 5 times this one, then 5 times this one. Then we do 5 here, then here, and then we collect like terms. And it can be a long, drawn-out equation that we just probably don't want to do. So this is the reason why, if possible, we're going to try to remove everything, the 5 in this case, over to this side in order to make the problem a lot easier to solve. So let's do that first. So let's not do this anymore. Let's move the 5 over. We're going to do minus 5 here, minus 5 here. And then we have on this, these cancel out. So now we have the square root of x plus 7 is equal to x minus 5. Now we can do our square on both sides. So we'll take this and square it. Put this everything, square it. This square cancels out with that square root, leaving it was just x plus 7. And here we have to, this is another little red flag that you don't want to do. I'll put it in red, so we don't want to do this. A lot of students just take this square in and do this. That's so illegal. The answer is x squared, and they probably say plus 25. That is such a no-no. Don't do that. Don't do that. Please get that out your mind. We're not doing that anymore in math. Because what this means is we're taking x minus 5 times x minus 5. We have to square it. So then we FOIL the problem to get our long that looks like x squared is 10x plus 25. So once you do your FOIL, come back, collect like terms, we get this equation here. That's the legal way to do it. This is the way I want you to do it here. So don't do the other stuff I had in red before. So now we're going to collect like terms. Once we collect like terms, I want to probably bring the x over here to this side. Oops, I'm going to put it underneath the x. Can't put it underneath that one because that's squared. And then we're going to do minus 7. Put it underneath here. So that goes away. That goes away. On this equal sign is equal to 0. So we have 0 on that side. That's the what we want to do because we always want to set it equal to 0 so we can solve for x. So here we didn't do anything with the x squared, so that comes down here. That's going to give us a minus 11x, and this is going to give us a positive 18. Now we got to kind of go back to our roots of how to factor this. So this is, again, you might want to brush up, do some YouTube videos, Googling, whatever you need to do to figure out how to take this and factor it. So this goes to x and x. This goes to minus 9 and then minus 2. Because this 2 multiply these two here gives me a positive 18. If I add them two together, negative 9 plus a negative 2 gives us the 11 in the middle. So I know I'm good to go there. So I set this one equal to 0, this one equal to 0. So my two answers is going to be positive 9 and positive 2. So going to the problem here, is positive 9 and 2 going to be my answer for this particular one? Again, you have to do the check because, again, one of them may not work. So let's look at the problem. We get our two answers. We notice that when we plug in the first one here of 9, plug it in, get 16, square it, get square root, get and 9 over here. So put 9 here, put 9 here. They both equal 9 on both sides. This answer is true. However, if I put 2 for x here and x here, this side equals 8, this side equals 2. This is false. So the only answer for this one is going to be 9 to be the answer. So be careful with that. Don't put both. The answer be 9 and 2. Got to do a check because maybe one of them be the answer. So here's our last one we're going to do. This one's going to take a little bit of time, so I'm going to actually work this one out for you. So here's the last example that I wanted to go over. Looking at the problem here, again, I want to try to get the square roots to one side because the last thing we want to do is take this side, square it, and then square it. That's going to be, this side over here is going to be really messy. Trying to square both of them. Again, this is another no-no. I think I mentioned earlier, but just want to keep repeating it. Do not take this 2 in and square that one and square that one, leaving with just x minus 3 plus x plus 5. That does not work that way in math. That's illegal. You're going to have to FOIL. So you have to kind of take it out and FOIL. But the last thing we want to do is FOIL 2 square roots. So I'm going to make the problem somewhat easier by moving one of the square roots to the other one side and just squaring just one of them because I don't want it to FOIL both of them together. So I'm going to take this one, take it over here. That way this cancels out. So on this side, I'm left with the square root of x minus 3 is equal to 4 minus the square root of x plus 5. Now looking at this one here, I can take this and square it. And now I have to take the whole thing here and square this one. That's the best I can do. I know I wanted to try to get the square roots to be both sides, but I have 2 of them, which makes it a lot more difficult, but it's doable. So I take this square, that cancels over here, leave me on this side x minus 3. Over here, I again do not take this square and multiply, square this part and then square that part and just put down 16 minus x minus 5. Don't do that. We're going to take this here and do 4 minus the square root of x plus 5, parentheses 4 minus x plus 5. You have to do it this way. There's no way getting around it. So if I multiply each part together and do my FOIL, on this side, I'm going to be left with 16 minus 8 square root of x plus 5 plus x plus 5 when I FOIL. So then I'm going to collect like terms. And just so if you're wondering, this 4 times this 4 here times this square root here is going to be negative 4, the square root of x plus 5. You don't take the 4 in and distribute it inside the square root. We're not doing that. And then if I take this part here, multiply it to this one here, that's also going to give me a minus 4, the square root of x plus 5. Because these both have the same square root, I can take the what's in front and add them together, which gives me the negative 8. And then we just write down what we have again. So this is where this came from, if you're wondering. So here we're going to combine like terms now. Once I combine like terms, I can take the x over here and get rid of the x's. So this minus x and this minus x, both of these go away. I have 16 plus 5, that gives me 21 with a minus 3 on this side. So let's do minus 3. This 16 and this 5 over here gives us 21 minus 8 square root of x plus 5. I take the minus 21 over. That gives me negative 24 is equal to minus 8, the square root of x plus 5. Now I take the 8. Let's get rid of that. By dividing, let's do the opposite. So divide on both sides. This cancels out with this one here. So over here, we're left with negative 3 is equal to x So here, because this side on the right side, the square root is by itself, I can do the whole method again by squaring it. So I can square this side, that drops the square root, that gives me x plus 5 on this side, that gives me 9 on this side. I'm going to take my 5 over by subtracting, and I have 4 is equal to x. Is this the answer? We don't know, because what do you also always have to do? Got to do the check. So once we do the check here, we get x to 4, plug the 4 in for here, plug the 4 in for here. If it equals to 4, then we did the problem right and we're good to go. If you have any questions or concerns about this section, please let me know.